Alright, hello guys. Right now we are trying to fix a test that Adam gave us. There's a struct with a bunch of substructs and we want to print at least the member names. Right now what we'll get is member names null for that thing. I presume because it didn't have semantic code on it. So we will do something in the variable expression thing here, and we will kindly ask to run semantic on the type that we get out. So if we get a type expression, we will try to see in which state the type expression is in. So we'll say te.type dot not zero, not line off, not basic off. There should be a D symbol somewhere. I'm not sure if it's directly in the type. Okay, here's the art expression node. Here's type. Those are statics. The type itself doesn't have anything that tells us immediately whether it has been resolved or not. However, there is something that we can check, and that's deco. The deco stands for decoration, and that is the mangle of the type, or the deco string in DMD talk. So we want to check that deco is something we can rely on. And I do think we almost have no other choice. And then we have to, if that is not the case, if deco is not set, we have to run type semantic on it and hope that comes back with something that we can use. So let's do that. First of all, let's check what type comes back. So it's a type bags, but the type is well, the type name of type is type name. Okay, now we should get that in our output, given that we recompiled before. Okay. we already get a type struct. That's good. But I would assume that there is no deco on that type. So deco is s, and then we do de.type.deco, and again the deco is the mangle, and for a semantically processed type, that mangle has to be known. Okay, this is the S, and for this thing that doesn't know its members, it still seems to have a deco, so that's unexpected. Because normally types that are completely processed would have a deco. One thing I can try and do is doing something horrible, just importing DNB type sem and say type semantic. Like, I'm just cold setting the type of this type expression because I have no other idea of what I could be doing. Long. And the scope is the CTFE global scope. And then we'll see if something changes. So no, nothing changes. The member names are still null. But at least nothing breaks. So this type is semantically processed as far as we can tell, even if it doesn't seem to have members yet. So we know that this thing is a type struct. Let's type. How do we do that for types? I think there are no helper functions on the type, so let's just say order ts equals if the type equals to struct, then say const type struct type, otherwise no. And then we say if ts, and we can make this one type struct if ts for each ts dot what we can do is try to ask for the merge too. But let's see what else can be done. So can we get at the members from the type struct, I guess is the question. Yeah, we would have to get at the symbol. We would have to go to the symbol and see if that symbol has fields, and possibly called semantic on the symbol. And maybe this will show us that the fields are not yet initialized. So we go through the fields. Printf. And we just print the field if there is one, which is the same thing we do in the for each. So actually that shouldn't change much. We shouldn't be able to get the fields, because if we were able to get the fields, we would see them here as well. So let's see. So we do see the XYZ, good for that, but if we look for field space colon, those are the only three we see. Which means that this fields field doesn't have any members for the other struct. So I would like to know when we see the type struct colon percent as on, let's say type struct sim, and then we do tsym the two cars, and then we can see if there is an if there is, well, there has to be a symbol, but we will see how that symbol looks, how the string representation of that symbol looks. And that may not look the way we want it to look. Type sim is just S. And here we have type sim item. So what we can do is we can try and calling the symbol semantic on type struct, on the symbol of the struct, and maybe I just do that. So we can just say that way the view symbol semantic won't be in a scope. And now that we call the D symbol semantic, right, we see all the fields here. So now that we have that, we can go to Atom and show him that this thing is much faster. After we comment out all the printf status, put that this way. I would like not having to call the D symbol semantic all the time, so let's just check what it does. To make sure that oh, interesting. Whether TS sim members is set tells us that we have to call semantic. I think. So if I do call this only when TS is set and TS members is not, that should change this to be working, I hope. So we should still see all those member names here. Oh, that's interesting. So that means ts.sim.member is set, but still there is no the symbol is not resolved. So how do I find out if a D symbol is resolved? There has to be a way. Since a struct declaration is a D symbol, I would assume that there is some field on there that tells us. There is something on there that has to tell us whether or not this declaration is semantically resolved. I would say. Yeah, there we go. Pass. The pass variable. Yeah, in semantic run. So we have to check where semantic run is at the stage where we don't get the names. So let's just ask for the semantic run property at the point where we see that. So that should be in the interpret. Yes. So that doesn't matter. Before we run semantic, I would like to know the value of semantic run. Ts dot semantic run, and after we run semantic, I would know it as well. I would like to know it as well. And then we can see what we have to aim for. Oh yeah, we have to run that on ts.sim. Semantic run is what we want to know. So let's check that one. Have we decompiled? Recompiled? Sure, yeah. Yeah, we did. So we're at semantic run 2 for the one we already know, and we're at semantic run 0 for the one we don't know. So we have to say if semantic is less than 2, we gotta run it. Yeah. FTS and ts.sim and ts.sim.semantic run is less than 2. We have to run the semantic run. We have to do that. We may even have to run semantic with the global CTFE scope. Not in this case, but if it is a different declaration, that might be necessary. So let's just do. Well, in this case, it can be null, but it really shouldn't be in the end. So now this will work for classes. And Adam wants to know how fast this runs and how much memory it takes as opposed to the regular run. So let's tell him it's, wait, that's weird. The change we did to this, if semantic run is less than 2, we want to run it. Yeah. So we are building a release build with tons and tons of debug output. I just want you to remember that, and we do get the member names as something we can use in our source program. So here's it. here is the member names, and it took no time at all, and what is this, 15 megs? Let's take that and divide it by 1024. Yeah, that's 15 megs. So that's something that we can tell Adam about. But since that is work chat, and I do not want to play with my employment opportunities, that's where it will be at right now. See you later when I'm solving another problem.